Alright, boys and girls, welcome back to the drive-through. A little 10-3 video here on circles. Okay? A circle, by definition, this is the definition of a circle here, is the set of all points in a plane equidistant from a fixed point called the center. You guys are probably familiar with that. Here's a little questions. What if I got rid of this phrase here? What is the set of all points equidistant from a fixed point called the center? That would be a sphere, okay? And we do have an equation for a sphere, and you'll learn that in multivariable calculus. But it's very similar to a circle, to be honest. Let's see if we can come up with, so let's say we have a circle. And let's say that it's centered at h, comma, k. We're going to use those a lot. And let's say this is our circle here. All these points that are r units away from the center. How can we come up with an equation that represents the sum of the points? Well, we know that the distance formula is x minus x1 squared Oh, hold on a second. This is the distance formula. What's the distance formula? Distance is the square root of x minus x1 squared plus y minus y1 squared. Well, in this case, all of these points are x, comma, y. We want all of the points that are exactly r away from h, comma, k. So that would work. Well, let me move this a little bit. Let's square both sides. So r squared is x minus h squared plus y minus k squared. And that is the equation of a circle. X minus h squared plus y minus k squared equals r squared. Keep in mind, for a circle, it is not a function. Look, this thing is failing the vertical line test all over the place. Not a function. Not a function, which is why we cannot write a circle equation as y equals. We cannot, because it is not a function. This is the general equation for a circle. Okay? So, if it's centered at 0, 0, and the radius is 3, it's x minus 0 squared plus y minus 0 squared is 3 squared, but we would never write it like that. It's just x squared plus y squared equals 9. That's the equation of a circle centered at the origin with a radius of 3. This one would be x minus 0 squared plus y minus 1 squared equals 2 squared. We wouldn't write it like that. We would write it like this. Now, don't FOIL this. Don't expand this. Whoops, excuse me, equals 4. Expand the 2 squared. Don't expand that. So that is the equation of a circle centered at 0, comma 1 with a radius of 2. So what is this? Well, we just got to now work the other way. So it looks like this point right there is 1, 2, 3, 4, 5. It's negative 5, comma negative 2. It looks like the center, it looks like from here to here is, how long is that? It's 1, 2, 3, it's 4. So here, r equals 4. The center is negative 5, comma negative 2. So this is x minus a negative 5 squared plus y minus a negative 2 squared equals 16. Does that help? I hope it does. And I'm moving on. It's going to be a quick video. Okay, let's graph these. So here, what's the center? The center is negative 9, comma positive 2, and the radius is 9. So I go left 9, up 2, and the radius is 9. Well, that's going to be kind of hard. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Down 9. And it's going to go just slightly off the page as it goes to the right. And it's going to look like that. Okay? This one has a center at 0, -3 and a radius of 11. I love this ViewSonic thing. It's going to be something like that, okay? All right, now, for completing the square. What if the equation looks like this? Huh? How do we make that look like this? Well, we're going to use this very common algebra trick called completing the square. If you had me for geometry, then you've learned this trick already. If you didn't, you've probably never done this before, but you're going to do it a lot for the rest of this chapter and beyond. The trick is to group and then group first and do this trick. So here's what we're going to do. X squared minus 6x plus y squared plus 14y equals 8. So literally all I did was change the order and add some unnecessary parentheses. Now, we want this to end up looking like this. Notice what's different. The square is on the outside of the parentheses, where here our square is on the inside of the parentheses. So this is where the trick comes in. So here is the trick. Follow closely. Create space. So literally just rewrite it with more space to the right. Now, what could I add here so that I made this thing a perfect square? The trick is take half of 6. So what's half of 6? It's 3. And then square that. Okay? And you might be thinking, what? You're not allowed to do that? You're right. I'm not allowed to do that. So let me add 9 to this side. And now I have done nothing illegal. I've simply added 9 to both sides. Why did I add 9 to both sides? Stay tuned. Now, what's half of 14? It's 7. Square it. 7 squared is 49. What? You're not allowed to do that? You're right. I'm not allowed to do that. So let's add it to both sides. Now, you might be wondering, what on earth did you do that for? Because I needed to, so I could write it like this. So now, can you factor this thing? Sure you can. I just made sure you can. What is the factor? It's x minus 3 times x minus 3. And what's this one? Well, it's y plus 7 times y plus 7. And what do we get over here? Let's see, you get 50, oh yeah, 63. I like that number. Okay. No, 64. I like that one even better. I like that one even better. 64. Okay. So, what have we done? Well, what's x minus 3 times x minus 3? It's x minus 3 squared. It's y plus 7 squared. And now we know. Got it. The center is at 3, -7, and the radius is 8. And that is completing the square. Boom!